Well, hey guys, it's about time I put up a video. Seems to be a trend on YouTube. A lot of the popular channels I like to watch hardly put up videos anymore. I guess I'm becoming like them, but hey, I'm trying. But anyway, I have this Kinter MA-150. It's a little 2-channel mini amplifier. I don't know what this digital player part is, but let's take a look here. Of course, we'll do the usual. We'll do the power test and all that good stuff, listening test. And get this package open. Oh great, there goes the noisy heater. But here it is. USB charger feature, audio in. It has a level control and a high and low filter. Aluminum casing and connectors. And I hope that there's... yeah, there they are. If I can get them out. I guess I have to open the other end. There they are. There is a set of wires, which is good because I don't really have a way to connect those up. Well, this amplifier I got from Parts Express for $13.50. If you remember, a little over a year ago I reviewed this one. I think this one's about 10 bucks or so now. I got it on sale for 7 something. But I'm kind of interested in why this one is more expensive. I mean, this has tone controls and everything, and proper speaker connectors. This is really just an amplifier, though it does have a USB port on it for charging purposes only. It doesn't really play anything. I mean, you can't put a USB device and play anything, as I understand. But that is what I got here. Here's a quick look at the manual and the specifications. It claims to be 20 watt per channel into 2 ohms. But above that it says output impedance 4 to 16 ohms. So what is it? I mean, how low of impedance speakers can you put on the thing? 12 volt, 5 amp, and some other specs here. Well, I think before I do the power test, I'm going to pop the top and reveal what's inside of it. And we're in. Uses this TDA 7375, so we'll take a look at the data sheet momentarily. Power comes in here, goes through this polarity protection diode. Main filter cap, 3300 microfarad. Some generic Chinese brand though, but it's nice to see they use that value. And this here is the 7805 regulator for this port, charging port, but the problem is it's not heat sinked. It's not, there was no screw or anything to bring it over to the side of the casing. You know, there's no screw hole or anything on that side. And if you're drawing, say, 500 milliamps and you have, you know, probably with normal cars voltage, you have about 13 minus 5 And that's about 8 volts times 500 milliamps. This thing has to dissipate 4 watts. Not going to do that alone. It needs a heat sink. So that thing is not going to last too long. It'll get hot, and the thermal protection will save it for typical with ICs. They're designed to save the things for about 1,000 hours or so. So maybe they're counting on that. I don't know, but very poor design there. And this is weird, this wire hanging here. Well, this has a cover that goes over and holds it to the side. No heatsink compound at all. And I guess they're grounding the, I should say they're putting this negative side to the casing through that film cap, because that's where it connects. This wire connects. So probably filtering RF only and not actually electrically grounding the case. And just other components, probably caps for this filter switch. And really not much else to it. Pretty decent layout. You can see the star ground at the capacitor negative terminal here. You know, grounds run off in their own direction. That's good. The only problem is I don't see a film cap across the supply and ground that's close to this chip. And you can have oscillation issues if you don't do that. So, you know, hopefully that's close enough so there's not problems, but normally you like to see a film cap across the supply rails very close to the chip. Okay, let's take a look at the data sheet of that chip. Okay, here's the data sheet for the amplifier IC. Ignore those stupid high power ratings because in real life you don't get that. But they actually used a much better chip than in the other amplifier. This will handle 4 ohms. It's bridge, so we should get very good power. I mean, we'll probably get around 10 watts or so, I'm guessing, before clipping 4 ohm loads with my power supply. But yeah, this is a pretty good chip. The other one, you know, it turned out to be a weaker chip, and you really couldn't hook up 4 ohm loads to it. And we got only like 5 watts out of it. Okay. Yeah, some distortion there. That's not too bad, really. Well, without further ado, we'll hook it up to power and do a listening and power test. Okay, have it hooked up to my speakers with its supplied leads. And I'll just power it with this lead acid 12 volt battery. It does have a remote lead that you have to tie together with the positive if you want it to turn on. And I'll play some music. I'll flip the high and low filter switch in and out so you can hear that. Of course, that's low pass. High pass. Normal. Well, the camera's the way it picks up bass, you may not be able to hear the difference with a high pass, but it does, you know, remove the bass. So yeah, the filter does work. I don't hear any distortion or any problems. It sounds nice and clean to me. Good frequency response. Well, I guess it's time to go on with the power test. Oh, before I forget, I did notice that having this turned all the way up and even my music player turned all the way up, it didn't get very loud. That's because of the gain. This is set up for line in, and music players do not put out enough voltage from its output to drive the amplifier. Not really a fault of the amplifier, it's just, because it's an actual line in. So to do the power test, I'll have to somehow increase the voltage. I have the non-inductive 4 ohm resistors connected to both channels. We'll do a power test, both channels driven, at the point just before clipping to see the maximum clean power from this amplifier. I'll try my CD player here and see how that works. Okay, well, it's up as high as I can take it. That's the filter switch, low pass. That's normal. And well, it's not clipping yet, so getting 5.75 volts RMS out. So I'm going to have to use something else. I'll just use my function generator, that cheap one I have over here. I don't like to use it because it has higher distortion, but here, looking at the distortion, there's no real distortion issues, just a little bit of background noise. But at least we can see there's not a lot of distortion. Well, I'm just having a hell of a time getting this to work. So I'm now feeding my music player into this amplifier, which connects to this output stage, which is I was going to make another video about. And the output of this goes into the input of this, and of course I've turned it way down since the output of this is quite high. But I know I'll be able to drive it to clipping. Okay, so you got this powering this amplifier. I'll turn the voltage all the way up. And here we go. Okay, let me adjust this. See, no distortion. You can see the spikes start to show as we start to clip. And I just want to tune those spikes out right about there. We were close. So we're at 6.1, we'll just say 6.1 volt. 6.1, square that, divided by 4, 9.3 watts. About what I expected. Now, the voltage of the battery dropped to 11.9 during the test. You have to remember there's that protection diode inside which takes some voltage away from the amplifier. So we're running about 11.2 volts or so. Now if I ran this at a supply around 14 volts, I probably could get around 13 watts per channel out of this thing. So I'm actually pretty impressed with this amplifier. I can run it with 4 ohm loads. I get a decent amount of power. Yeah, it says it's 20 watts per channel, but of course, that's that 10% rating, which you can't achieve with clean power. And a couple other measurements I took with this amplifier. The quiescent power draw, or I'm sorry, current draw, just meaning no load or no output signal, is 120 milliamps, and with the remote power control lead removed so that it's still connected to the battery, but it's off, I was drawing 4 milliamps. So there you go, pretty decent little amplifier that can actually handle 4 ohm loads, whereas the MA-170 could not do it. due to the chip that was used inside. This uses a better chip, so no problem there. So would I recommend it? Yes, with reservations. Because of the voltage regulator chip used inside, I would not use the USB port on this thing unless you're sure you're not going to draw any more than 100 milliamps off of that. Now if you want to hack it and properly heat sink that voltage regulator chip that's inside, sure, you could use it at higher current. And you know, if you're going to use a music player, it's not going to have enough gain. You're going to have to use some sort of preamp because they use the standard line-in type levels for it. Well, that's it. Thanks for watching.